Good afternoon, everyone. Good afternoon. Hope all is well and everything's all right. Oh yeah. So pretty sure you guys saw the message that classes are shutting down, even online at 2 p.m. So yeah, appreciate it. Appreciate it. So I will, have a short class. I mean, I didn't want to create confusion by canceling and people coming in and just I was like, all right,
Wait,
it's
is it
fine.
because of the snow or COVID?
Snow, because of
Yeah,
snow.
I was just wondering because
Mhm.
I was asking my mom about that this morning. I just want to make sure it's not nothing about COVID. It's because of the snow.
Inclement weather. Yep, yep, yep.
I was just wanting to make sure
Oh no, you're fine. You're fine. You're fine.
because back in high school, because during my last year of high schools, it got shut down because of COVID.
Mm, gotcha, gotcha.
Well, Bill, I guess it's not gonna be able to shut down since it's currently not as bad as it was during 2020.
Right, right, right. Yep.
And people
Hopefully we
are
can.
being more careful.
Yeah, well, we hope we can get to get this thing under control very soon, so we can get things back to normal. All right. So,
Oh, 1 second, I
uh,
had to step away from the webcam for a bit.
okay, not a problem. Not a problem. All right. So we ended up. This was 5-3. We stopped right here at signs of trig functions. So we're really gonna, and we talked about it a little bit last class about how your signs will be different depending, because we're leaning on the Cartesian coordinate plane. Your x-axis, horizontal axis, y-axis, your vertical axis. So those same thought processes we're using here. Um, we already talked about how you have your x and y coordinates, x and y components of your coordinate, and cosine is your x, sine is your y. So here is a way that we can, and I think, yeah, I did write it under here. A way that we can remember what's supposed to be positive and what's supposed to be negative, according to your angles and what degree you're in. And don't forget, also, I didn't write this up here, but this is 0 degrees slash 360. This is 90 degrees, 180 degrees. This is 270. So when you're talking about degrees of your angle, anything between 0 and 90 will be in this first quadrant. Anything between 90 and 180 be in the second quadrant. Between 180 and 270 will be in the third quadrant. And then between 270 and 360 will be in your fourth quadrant. All right. So a way we can remember our signs. So all of your trig functions will be positive in the first quadrant. Sine and its reciprocal, which is cosecant, will be positive in your second quadrant. Tangent and cotangent will be positive in the third quadrant. And then cosine and secant will be positive in your fourth quadrant. So a smart trig class, A is for all positive, S is for sine is positive, T is for tangent positive, and then C for cosine positive. Aligning up with quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, yep. And so once again, along with sine comes its reciprocal, which is cosecant. Along with tangent comes its reciprocal, which is cotangent. And then with cosine comes secant. They're reciprocals of each other. Any questions? Everybody good before we use this? Give you guys a chance to write it down before I scroll up. Okay. All right, can we scroll up? We good? All right, see some head noddings, okay. So let's look at this first example. So it says if tangent is less than 0. So if it says it's less than 0, they assume you know there are only one type of numbers that all of them are less than 0, and those are negative numbers. Same thing with it being greater than 0. That means we're talking about positive numbers. So what we're saying here is that tangent is negative and cosine is positive. And so name the quadrant in which angle theta lies. So tangent theta is negative, cosine theta is positive. What matches up with those two characteristics? So in the red was me, what I did was I listed out all of the quadrants that has tangent as negative. So, you know, quadrant 1 is not the case because quadrant 1, all of them are positive. And then quadrant 3 is not the case because we know tangent is positive in quadrant 3. So that means quadrant 2 and quadrant 4 are the quadrants where tangent is negative. Then we're looking at the quadrants where cosine is positive. So that will be the first quadrant because all of them are positive in the first quadrant, and quadrant 4 because, you know, we go cosine is positive in quadrant 4. And so the one that matches with both of them is quadrant 4. So that means we are talking about an angle that is in quadrant 4. Any problem with that? So that's all they wanted from you in that case was, you know, with those characteristics, those initial conditions, which quadrant would theta be in? Scrolling up, you okay? All right. All right, so here we're given a little more detail. It says given that tangent theta is equal to -2/3 and cosine theta is greater than 0. So in other words, cosine is positive. Find the missing trig functions. All right. So let's look at our given information first. So the green is the given information. We got tangent theta is -2/3. And remember last class, we talked about this relationship that tangent is always going to be y/x. Also, note right here in red, r is going to always be positive. So if I have r involved in my relationship, remember cosine and sine always has r involved in your establishing of your numbers. R is going to be the positive. R is always positive. Okay. So remember we talked about that cosine is x, y is sine, and this says that cosine is greater than 0, cosine is positive, so that means x is going to be positive. Remember cosine and x are the same thing. So we want to find the missing trig functions. We need r. We have x and we have y that was given to us from tangent. We can establish, and also I want to make sure we're okay with why we had to have this piece right here, that cosine is positive, because this minus sign that's on this 2/3, you could have assigned it to the 2 or the 3. So don't forget, -2/3 is the same thing as 2/-3. Both of those are the same number. Just that the minus sign is at the top, one is, you know, one is at the bottom. You divide it out, you're still going to get -0.6, you know, repeated. So we don't know right here which one of those will actually take on the negative sign, but this is the one that tells us that x is the one that's positive and then y would be negative. So that's why that's important there. All right. Any questions before we find R? Everybody okay? Okay. So finding R, remember the formula for R is, you know, the square root of x squared plus y squared. So that gives us a square root of 13. Any problems with R? All right. So now we have X, we have Y, and we have R. And we can go ahead and plug it into the relationships that we initiated last class, Y over R for sine, X over R for cosine. We already knew what tan was. They gave that to us. But here, -2 over the square root of 13. Just Y over R. Don't forget to rationalize your denominator. So multiplying top and bottom by the square root of 13. That's -2 square root of 13 over 13. Same thing happens here for X over R for cosine. That'll give us 3 square root of 13 over 13. And like I said, I just wrote the tangent one out of habit, just going through the trig functions. They gave us tangent initially. And then cosecant, secant, and cotangent, you reciprocate cosecant, you reciprocate sine. So that'll be square root of 13 over -2. Secant, reciprocate cosine. That'll be square root of 13 over 3. Basically, reciprocate is just a fancy word for flipping the fraction, right? So all we do is flip the fraction. And then the last one, you flip tangent, and that'll be 3 over -2. All right, so everybody good? Everybody straight?
Yes.
Sounds good, sir. Appreciate it. Anybody holding on to cotangent? All right, so let's look at reference angles. So let theta be a non-acute angle in standard position that lies in a quadrant. So if the angle is acute, it does not need a reference angle. So we're talking about anything larger than acute angles. Its reference angle is the positive acute angle, angle prime. I said angle prime, theta prime. That's what we say right here when you have that apostrophe like that. Theta prime formed by the terminal side of theta and the x-axis. Give you a chance to write that down. All right, so here's just diagrams of what your reference angle would be according to the definition that we just discussed. If your theta was in, first one would be second quadrant. So notice your reference angle would be right here. Remember, it's formed between the terminal side and the x-axis. So if your theta is in the third quadrant, so your reference angle would be right here. And then if your angle or theta is in the fourth quadrant, your reference angle will be here. All right, so let's find the reference angle to each theta given. All right, so we're going to find the reference angle for each theta. All right, so the first one, probably could have wrote it a little better with the color code and I had my spacing. So we have 345, and we want the reference angle for that. So 345 degrees is in our fourth quadrant. So that means theta prime would be over here. So you would just do 360 minus 345, and that will give us the 15 degrees right here. Hold on a second. Oh, I'm about to say, why didn't I put B? Okay, I'll let you go ahead and, why did I do it like that? That's weird. Hold on one second, guys. Just looking at what I did here, why I did it this way. Yeah, that's kind of crazy. You know, that if someone must have asked a question, that must be what happened. Okay, well, let's look at these, not these yet. Somebody must have asked a question that took me here, but that's a good example, so we might as well look at it. So over here, if I have an angle that's 160 degrees, and I want to know the reference angle, and we'll get to B, C, and D in a second, but since I have these over here, we might as well just talk about them. All right. So we have 160 degrees, so we subtract that from 180, and that gives me the 20 degrees that's right here for theta prime. If my angle is in a third quadrant, let's say 225 degrees, so that'll put me right here as far as my reference angle is concerned. Then I will subtract 180 from it. So you notice the difference in what we would do. So going back to our initial one, if it's in the fourth quadrant, I subtract it from 360. If it's in the second quadrant, I subtract it from 180. And then if it was in the third quadrant, I'll subtract 180 from it. And that give you 45 degrees. One second, did I not write this? Anyway, thought I wrote that somewhere else. Anyway. All right. As a matter of fact, let me do this. All right, so I thought for sure I wrote that somewhere, but evidently I didn't, or maybe it was for another class. So there you go. That's a summary of finding theta prime. If theta is in quadrant 2, then you would do 180 minus theta to find theta prime. If theta is in quadrant 3, you would do theta minus 180 to find theta prime, or in other words, find your reference angle. And then if theta is in quadrant 4, to find your reference angle, you do 360 minus theta. So like I said, that sums up what I was doing over here in that first problem. Everybody good? Can I scroll up? We go to B, C, and D. Like I said, sorry about that
Yes.
confusion. Thank you, sir. Sorry about that confusion. Like I said, somebody must have asked me a question last time I taught it, and I went over there doing stuff, but it's all good. So the next one we're looking at is theta being 5 pi over 6. So if you're not that, let me see, how can I say it, not that fluid with knowing the value of 5 pi over 6, you can always convert it to a decimal and put it in your calculator. And that's what I did right here. And so that's 2.62. And so you want to know where would that be in reference to your angles in radians form. So you would just look at all of them, pi over 2 is 1.57. And if you throw it in the calculator, pi, which would be 6 pi over 6, same type of deal, is 3.14. So you're talking about being in between 1.57 and 3.14, which is pi. All right, so is everybody okay with that before I go any further? The positioning of 5 pi over 6. Remember, where it lies as far as our quadrants are concerned will dictate, which one of these we do as far as the summary that I just wrote down. All right. So it's in the second quadrant. And remember, we just finished saying if it's in the second quadrant, we're going to do 180 minus theta. So 180 as radians, in radians is just pi. So that'd be pi minus 5 pi over 6. And so don't forget when you're doing the subtraction or adding of your fractions, then you have to convert to a fraction with the common denominator. So that's 6 pi over 6. Subtracting that would be pi over 6. All right, questions before we look at the next one? That's one like this. All right, so negative 135. So we're looking at, going in the opposite direction of our angle. Normal angles, remember, standard position, and going counterclockwise is positive move. Going clockwise is negative. So here's just a little diagram of that. Going negative 135, negative 90 degrees would be down here because positive 90 degrees would be up. So negative 90 degrees would be down here. And why did I write this so sloppily? And so that means negative 135 would go to our third quadrant. And this is how we can make that happen. Doing 118 minus 135. And that'll give us 45 degrees. So stuff is just a little reversed because we're dealing with a negative angle. And that should have been negative Hold on a second. 45 degrees. So then we'll have to, did I not write the 225? Not 225. No, I was just thinking of something else. Okay. 45 degrees. All right. Any problems before we look at D? All right, last one. Yep, last one. So 2.5, using it the same way I mentioned before, where since we have it in decimal form, we need to convert, and it's not degrees, it's radians. So we need to convert all of our radians to decimals in order to, unless you just, already got it programmed in your mind what decimal values go with which radian measure and everything. So 2.5 will be in the second quadrant. So we would do pi minus 2.5, which would be approximately 0.64. All right. So let me see, is this a good place to stop? So let's go ahead and do this, and then we'll be done for today. Anybody still holding on to this reference angle? Anybody? Okay, so let's just use the reference angles, and then that'll be it for the day. So using the reference angles, you're going to use the reference angles to find the exact value of certain angles. All right, so these reference angles, if they have those familiar angles that we talked about last class, if the reference angle is 45, 30, or 60, then we know it's only but three options we have there. It's either going to be 1/2, square root of 3 over 2, or square root of 2 over 2. Those are the only three options as long as 45, 30, or 60 pop up. Those are our familiar familiar angles, common angles, special angles, whichever way you want to call them. So the first thing we want to do is find our reference angle. So to find our reference angle for 135 degrees, we will subtract it from 180, and that gives us 45. Now the sine of 45 degrees is the square root of 2 over 2. Because remember, we're looking for the sine of 135. So once we find our reference angle, find the sine of 45 degrees. So whether you commit it to memory, use the unit circle, or use that chart I gave you last class that gives you all of your special angles, whichever one is fine, but you want to make sure you know which one is which. And you want to do your best to commit it to your memory, because even though I'm not holding you to it, especially it's hard for me to do it through virtual and all the stuff like that. Next semester, you may come across a calculus teacher, if you have to go to calculus, that wants you to know these. And so you do want to do your best to try to commit them to memory as much as possible. So sine of 45 degrees is square root of 2 over 2. Then you need to check your sine. So we're in the second quadrant, and that goes back to a smart trig class. Since we're in the second quadrant, your sine and its reciprocal will be positive. So our answer is going to be positive square root of 2 over 2. If we were looking for cosine of 45 degrees, it would be negative square root of 2 over 2, because in the second quadrant, cosine is negative. So knowing which quadrant you're in will dictate the sign of sine, cosine, tangent, or any of your trig functions. All right, any problems with A before we look at B? And here in the black, I was just, re-emphasizing what I was saying about the unit circle and how there are only 3 shots: square root of 3 over 2, square root of 2 over 2, and 1/2. So I was just talking about that with that. Okay, I didn't write B here, but this is B. So looking at cosine of 4 pi over 3, once again, you want to make sure you establish what quadrant you're in. Whether it be by, like we did last exercise, whether it be by the decimals or, your placement according to pi, whichever way, make sure you find a system that works for you. because it will be important that you're comfortable with knowing where your quadrants will be once we go into radians. So this will put us in our third quadrant. And if that's the case, going back to what that summary I gave, if we're in the third quadrant, we're going to subtract 180 from our angle that we're dealing with. So that means we're going to subtract pi. Pi and 180 are the same. So for pi over 3, subtract pi. Pi, we have to convert to a fraction with a denominator of 3. So it's 3 pi over 3. And that'll give us pi over 3 for our reference angle. So over here, cosine of pi over 3 is 1/2. And now it's just about establishing the sign that we will have for cosine in the third quadrant. And because we're in the third quadrant, quadrant 3, cosine is negative. All right, so that's why cosine of 4 pi over 3 will be negative. I can get that note. All right. Questions. Make sure we're okay. Everybody good, everybody straight. Yeah, I'm just playing around with notes and colors right now, just making sure everybody's done copying.
Okay, I'm fine.
All right.
Wait, oh my, we're not done yet, right?
Yes, we are. That closes out
Okay.
5.3.
Okay, I'm fine.
All right, take care. All right, guys. So any questions before we close out? Trying to adhere to TCC's policy for today of closing out class at 2 p.m. But I at least want to get out of 5.3 since we were there and almost close to doing so. All right, sir. Take care. So if you guys are good, I'm good. If you have any questions, make sure shoot me that email. I know some people send me a question. Somebody sent me a question recently, so I'll respond to that shortly. Outside of that, you guys have a good one. Be safe. Have a great weekend. Be careful with the snow. And yeah, that's what I'm saying as well. Be safe in the snowstorm. And you guys have a great one. See you on Tuesday.
Thank you, sir. Take care.
Thank you. Have a great weekend.
Thanks. You do the same.
Have a great day.
Thanks. You do the same. Can you post a chart with the quadrants? Post a chart with the quadrants. Are you talking about what I wrote? We say post a chart with the quadrants. Who said that? Yeah, Miss Hill. Miss Hill, is just you in here now. So we say post a chart with the quadrant. Okay, let me see. The one with the different degrees. Oh, the unit circle. Are you talking about a unit circle? Okay, yep. I'll send it to you guys before the day is out. All right. No problem. You have a good one.